right, so what we're looking at here is Trifiler galore. We got an SSG circuit. We got two Trifiler coils, one being run by a 1-2-3 circuit. So you basically got your base, your collector, and your emitter connections. You got a light connected to your collector and emitter, so it crosses those. And then you've got your two trigger inputs. Well, this is the ground. You just ground it to the emitter, and that way you can use a nice little battery circuit. All right, and over on the other side we got an SSG. So I'm going to hook up the multimeters, both of them, to the individual Trifiler strands. We're going to see, which coils are making the most energy on their Trifiler strand. So we got a 24 gauge strand on this side and a 22 on that side. 350 turns on this side, 666 turns on that side. Yeah. All right, pardon my garb. This is as close to a lab coat as I could get currently. I need to find one that'll fit me. Can't wear one that's all tight. All right. We got a counter-rotating pulse motor right here. And we got the 22 gauge strand hooked up to this multimeter. And when we get both of these coils firing, this thing's going to go 3,500 plus. They're both 20 gauge drive coils. It's going to be pretty awesome. So I'm going to get everything I need to monitor that. Which would be the tachometer. All right, we're going to turn on now the SSG. It currently is hooked up we're getting 15. It's hooked up to the light in the corner. If you can't see it, I will adjust. The black light in the corner. Okay, so the light is in the output at currently. And now I'm going to connect the ground of this circuit, and this should fire right away. Turn on the multimeter here. And these are all AC readings currently, no diodes in effect. 14 volts. 14 volts off of this coil. It's going to be 15 pretty soon, and 14 off the other coil. 15. That's awesome. So part of this is the induction, and part of this is the transformer aspect of the whole thing. So you get like 5 volts just for turning it on. Now we have our light that goes across the 1-2-3 circuit, and it's getting kind of bright. This coil's running off of this battery pack right here. like we've reached like a happy equilibrium. It might skip past this, but right now we're at 2650. That's still pretty fast, and then we've leveled out on the voltage output, which is 1759, 17.5 AC volts, and 13 on the other side. Just looking to see if there's anything I can do differently here. It's pretty good, I think. Alright, let's try this. I think this is what's going on here. That's too far. No, sir. This is a pulse motor. 3,000. What we're aiming for is about 3,000 RPMs. There we go, 302. That's awesome. Now, just to double check, I'm going to do the magnets. That's what we get reading the magnets. There's 4 of them. Yeah. And then we're getting about 20 AC volts off the end of this. The Trifiler strands. I don't know. There's so many different things I could try to hook it up to. See, without it being plugged in, we're only doing 5. Instead of 16.8, we're doing 5.8. Oh, it looks like it's picking up speed too. With that one being off. Huh. Yeah. Wow. 3,200. Yes, sir. I wear glasses. 3,300. All right, we're gonna cut this down. That's awesome, man. That speed, and I bet you the torque isn't bad either. But from start, I bet you the torque is lousy. Like from get-go, it's not going to be that strong. But once you get some momentum and like all the forces flowing your way, I bet that would, wrap a string pretty fast. But I don't know if that's like how you measure it. I don't think so. But this coil right here, I just busted it out to experiment with it. It's 666 turns of 20 gauge, 22 gauge, and 30 gauge. But this is the one that I made for tonight. It's 24 gauge and 2 strands of 32 gauge. It's a little bit weaker coil in regards to power, but it's pretty smooth. It's definitely a smooth coil. Smooth operator. I want to check out this Big Red by itself though. Awesome. That's cool. So I'd say that's all right power-wise. Just that red coil. Let's see what the speed is. Oh, it's only like 1600. That SSG really rips, man. That's alright. So yeah, I'm gonna turn that one off again. We gotta come up with something we're gonna hook the strands up to. Could be like a cap bank or just a cap, maybe 2 caps in parallel. I don't know, but we'll figure it out. So I think this rotor is a pretty good build on a 1/4 inch shaft, because it'll spin for, depending on what's next to it, a very long time after I turn it off. I know that doesn't, it only means one thing to me, that it's a very well balanced rotor. What that sound you're hearing is the magnets have about a hair to move around so that I can take them out easily. So that's them banging on the sides of their holes. That's what that's what that sound is. And it starts sounding like a, I don't know, a friend of mine said that it sounds like the nacelles in the old Star Trek. Oh man. So I got a lot of things that I got on the burner. One is a dual relay. A switching mechanism for swapping batteries for the SSG, or in this case I'm going to be swapping input and output, and the batteries are going to be stationary. So instead of having the batteries be on 1, 2, 3, and 4 alternating relays, I have 2 relays, so that's how we're going to do it. We're going to have input output alternating on 1, 2, 3, and 4. We're going to have battery on 5 and 6, and then we're going to have PWM MOSFET trigger for duration of pulse. So basically how long it's going to be off for, and then how many pulses when it pulses. So it's going to have one big gap and then one pulse. And that pulse is going to trigger both of the relays. And then bam, you got your swap. It works in theory. I'm telling you though, you can't just clip this together because it's not going to work like that. There's way too many things that could go wrong. So you need a really solid connection. And then I think you can do it either way. Either, swapping the input and the output, or you can swap the batteries and have one relay be for input and one relay be for output. I think that either way, as long as the timing is right with the switching, should work. Because it's going to have the same effect. Is that one battery is going to be going in, and then it's going to be going out. And, it's awesome that the relays function like that. Lots of stuff I want to play with. Lots of things I've gotten in the mail. Let me show you a few of these things. All right. Unboxing. Let's see. Opening. This is a ZVS circuit. Really cool. I'll get into that. Now, by recommendation, I was recommended to get these. These are 2 film capacitors that are going to replace the capacitors on the ZVS. Among other things that I have acquired in the last month, soldering kit, which I do believe I'm going to need in order to replace those capacitors. Yeah, Mike. Woo! Good to see you, man. All right. So we got capacitors, ZVS, soldering kit. I think we can start making like the first part of a Tesla coil assembly. And I believe the DC flyback is included in the ZVS circuit. I'm not entirely sure about that, but that's what it said in where I bought it from, but I'm not sure that's right. All right, so let's fire it up. We got the AC readout. for the 24 gauge strand in the Trifiler. We do have the SSG light on currently. I don't know why it's on, but it will go off once it gets spinning. That's it's odd. I really can't pinpoint why that is, but it's going now. It might be because there's too much amps going through the 20 gauge coil. It doesn't make sense though. Yeah, I know. I know it shouldn't be on. Well, it's off now. Man. I wonder what it could be though, because it shouldn't be on at all. And we'll hook up this one too. Alright, we're going to get our readings on our Trifilers real quick. Alright, 15, 16 volts, 14 on the other one. Now you can hear the coil is kind of struggling a little bit because of the different sizes, but it is the same gauge. $3,000. We're getting 15 AC volts here, and I think 16 on the other side. Plus the output LED. So currently I have that LED in the corner plugged into the output. It might be a little too light for it. I have to get a bigger light. Now, I have this relay circuit that I'm working on. I'm not doing that right now. I'm not doing that on a live stream. There's way too much that could go wrong. I don't have the right connections for the relay. I don't but I think my idea is sound. It's not my idea. That's why I think it's sound. And that's, instead of doing a battery swap, we do the input-output swap. As long as the timing's right, it should work, I think. See, yeah, okay, as long as I get to use your software, Mike, it'll be awesome. I'll do it on your stuff. I don't have any of that stuff. That's why I drew it by hand. So like 17, 32 volts. And what to do with that 32? I think we can hook up a few flyback collectors and then run those in series, and gonna try and run another motor with it. Sound like fun? Yeah. Well, yeah, that sounds like fun, Mike. I'd love to get it so you can read it. That would be awesome. I know that my handmade diagrams aren't up to snuff, but I try to explain them the best I can. So just under 3,100. That's awesome. But we're definitely getting more off the 22 gauge strand with the 666 turns than we are getting with the 350 turns and the 24 gauge, which is interesting because 24 gauge is supposed to give you more, and I think it does, of the induction electricity. Like right now, we're generating 3.5 volts just from the magnets passing the copper. And on the other side, we're getting 5. So yeah, you get way more from the spinning of magnets with the smaller gauges. And that was demonstrated also in this one. Because this coil right here is 777 turns, 777.7 turns of 24 and 2 strands of 32. So that's awesome. I mean, just from it spinning like this, we get about 8 volts off of this coil against the 2.3 we're getting off of this one, and the 3.5 we're getting off of that one. It's really awesome. I don't know if that electricity though counts as anything more than froth on your beer, but it registers. So I mean, you can't necessarily say it isn't there, because it is there. It just can't do anything. But that's not true either. It can light a light bulb. All that froth can light up a light. That's why I like, the electricity that I'm talking about can run a 3500 DC motor for 5 minutes. Like not just a burst, but like actually run it. And that's what I literally, since I started doing this, that's what I've been trying to do. Get one to run the other. And there are a few ways that we found out how to do it. One is to connect the collector directly to the next circuit. So the power is like a powertrain. And that's a good way to do it. You literally get probably, if you put 12.5 in, you're getting like 12.1 to go on to the next circuit. So that's awesome. What I mean is you clip the wire with a diode facing away from the transistor directly to the collector. And that's another way. That's a way you can run another circuit that can run another motor. Really cool. I kind of want to hook this one up though. It's really rolly though. It rolls around a lot. So the 32 gauge strands are identifiable by color. You got one red one and one gold one. So the gold one's going to be our trigger. Put the power in. Put this up here like this. Hook this to the red one. This is the multimeter, and it's cool because 32 gauge strand gives readings that are way different. I mean, they're going to equal out, but and those wires need to be re-evaluated. They're just all over the place. And we should be getting a reading already. Oh no, not quite. All right, just making sure everything's good. All right, so this is 24 gauge and 2 strands of 32. We're up to 3 volts right now. And it's 777 turns, but you can see it's on a longer bobbin, so the saturation isn't as good, but we're gonna get going pretty good, like pretty fast. Yes, I have many of those diodes, the little tiny ones, right? So you're saying if I hook up the BEMF capacitors, I should use one of those diodes? Yeah, I think that would be awesome. So actually it's nothing special. We're getting about 4.5 volts off of this coil. That's actually not that great. That's okay. That's okay. We're getting some all right speed off of it. I think about 1500. I want to say. It is a 24 gauge coil. So it's nice and smooth. We're getting about the same amount off a 14 gauge coil or 32 gauge over here that we are fully saturated over there with that one not being on. That one's not on. This one is on, and it's only getting 4.5. So this one is way better for generation, and I knew that. I wanted to fantasize, make this one seem better than it was, but I mean, I think it's all right. It's not the best coil. No, it is not a 3-phase motor. I could make it a 3-phase motor, I think, with the coils I have just lying around, though. Alright, we're gonna hook up a light that requires more wattage. I don't know if this is going to help, but we're trying to get the light to stay off. I don't know why it's on. I think it has something to do with the Trifiler coil and the way it's hooked up. Because I would use the BEMF and then I would flip it over. The BEMF way would make the light turn on. And the other way, the way that just collects energy off the strand there. Oh, we're good. The light works. Okay. Perfect. No light. That is so good. All right. Now it's good to start this one up first. And then start the next one up because that bench power supply doesn't like it when it's spinning really fast. Here, let's take a look at the magnetic field. These are 4 magnets facing outward, north out. Oh yeah. Lots of south in the middle, going all the way up to right about here. The extent of this ability to read the field goes all the way up to here. Right there. It's pretty high. I mean, that's awesome considering it's all condensed in the middle. $3,300. I'm gonna cut it back. Awesome. Alright, so I'm going to use one of these diodes to hook both of the Trifiler strands together. And we're going to see if hooking them together and then running the BEMF capacitor on them will be better than just running BMF capacitor on each coil and then linking them together. Now I do want to use the other coil. I do like that coil though. I can spin the sphere on that coil. It's pretty versatile, but it's just not that strong. So we're going to hook one end up to this multimeter. Alright. This is a 30 gauge trigger, so it's pretty neat. I don't see many 30 gauge triggers, but they work. Alright, so now we want to take our 32 gauge strand and we want to hook it up via diode 1N47 4007. One of those ones. 4007. I don't know how you want to say it. So we're going to rectify it and have it be fast switching into the next Trifiler coil. All right, so just one of these little bad boys right here. Now we're going that way with the diode. This way. Boom. All right. That was another 1, 2, 3 circuit that I was trying to run, and it didn't want to do it within the same coil. You know, run the Trifiler on a completely different transistor as another part of the motor instead of a generator. It didn't want to go. I think it's because my transistors weren't right, but maybe not. I don't know why. Sometimes it works, sometimes it doesn't. And yes, it does work, so I tried it. Don't know why it didn't work. It's a totally different coil though, for sure. It's a different coil. It's probably what it is. Less inductance or something like that. All right, so we want to take this end and hook it up to the other multimeter. Now effectively I've connected both Trifiler strands, and I don't know if it's DC rectified. I don't know if it is or not. We'll find out what we're getting from this coil in just a second. And then I'll hook a capacitor and a few more diodes up, and we'll start collecting stuff. Might even use this scrubber right here. All right. Now, I'm half expecting the light to be blazing. Let's see what happens. Oh, dude. Oh, we're good. We're good. We're so good. I'm sure that multimeter is good. Half an amp draw. That's so cool. All right, let's light this up. Looks like I got it backwards because we got negative voltage. Oh, that's because it's still DC. I think. No? So I'm effectively, I guess, using all the energy now instead of just cycling it. But let's hook this up. There it goes. I had it hooked up to the wrong strand. Okay, here we go. Rookie mistake. So I'd say it's not much difference. Unless I hooked it up backwards, which I don't think I did. Oh yeah, that's the difference. No? Man. 16.5 AC volts coming off of this double stranded thing that I've got going on. Oh, nice. All right. Not the most beautiful thing in the world. We got some kind of wave going here. So that looks backwards. See you later, Mike. All right. I'll get a hold of you, and we can talk about that if you want. I'd like to, so I'll try and catch you later. Now we're not going to move a bunch of stuff around. There we go. So I cut one off. Huh, it doesn't look like that one was affecting it except for the speed in any way. Take the power off of that one and you lose one of the spikes. But here, let me turn that other one back on now. And see what happens. Slow this down a little bit. I think it's going to be just using the one coil, honestly, is probably going to be the best bet for everything. It's 350 turns, pops like magic. I mean, having the other coil, you get up a little bit more RPMs, but this one alone works very well. All right, let's look. Oh, wow, what a wave. When it starts off in the beginning, God, there's so much I got to show you. Look at that. And then it gets going so fast that it turns into one, basically, one cycle or something. See, they dissipate as it gets going faster and faster. Now that's a strong boost to torque, I would imagine. It's getting where it needs to go faster with the coil than without it. It might not end up going as fast as it would without it, but it gets there faster. So 2700. I could back that coil out a little bit too. Back it out a little bit. Nice. So it's about 113 volt spikes max right now. And that's all right. That's 24 gauge and 22 gauge. $3,066. Beautiful. $3,140. Let's see about the magnets. 12,612. Heck yeah, man. Alright, now with it backed out all the way out here, I'm going to try turning it on again. See if the magnetic field from the rotor is far enough to reach it. Like 3,160. I can't really tell whether it's on or not. Yeah, it feels on to me. Heck yeah. But even getting that coil even a little bit closer is actually slowing it down. Yeah. Yeah, 3100. That's it. It's max speed for right now. Back this out even farther. $31.75. You can tell it's working by the 2 spikes in the oscilloscope. I need to switch it though. So we got 2 spikes in it instead of just the 1. It's awesome that it's working this far back. It's awesome. You know, it's actually generating enough to trigger this far away. See, now that's too far. There it is. That's max Q right there. So, what I mean by that is at 3,200 RPMs, it needs to be this close for it to work. $3,200 RPMs. With both coils functioning, of course we aren't quite a ways away, but it is on. Awesome. That's awesome. That's one of the few times I've actually seen that light up down there on the table through just induction. That's awesome. That's going straight through the SG. I don't know if it's that good for it, but I just turned that circuit off and we still got electricity flowing through the output. So I think it funnels the induction AC as well as the DC current and output. Does both. So yeah, I want to get. I'm not going to move forward with this until I get the proper connectors. Then I'll move forward with it. I'm asking around what type of connectors. Let's run this. I love this thing. That'll get going on its own. That'll get going about 1,000 RPMs. And level off. So, I mean, it's relatively safe. I mean, probably slap a sticker on it. So neat. Now the bottom is a lot heavier than the top, so I'm happy that it's going as fast as it is, especially with all the friction involved with this build. I don't have any of the maglev set up, so it's basically just chilling on a coupler. All right, so so 3,032 divided by 3, and that's basically its max speed with the one circuit hooked up. It is a 20 gauge circuit, so the other circuit won't help it out that much, but it's a 32 gauge of the same length and configuration. So they're all bifilar coils with 20 and 32 gauge. But like I said, only one's hooked up right now. The other one keeps frying. It keeps blowing transistors. I don't want to mess with it right now. It's obviously something's not right with the connection. It might be the fact that I'm using a breadboard and 24 volt input. That could be it too. This is a 24 volt input. There is a third battery. I don't use it because it will blow out virtually everything in here on the breadboard. Now, if I got a PCB and a solder action going on, I might try the third one. And that would be a 36 volt pulse motor. But it is very much so just a motor. There's I mean, even there's electricity being generated I mean, I was gonna make a commutator plate just for the multimeter, but I don't, there's no point in measuring this, really. You just, well, there's a, yeah, no, I can't say that. There's so many readings that I'd love to get off of this thing. Like when it, counteracts, like how much more output do we get per instance than it just going without, if there's any increase in output, that would be so fun to figure out. So I might make that plate, just two plates, one for the positive, one for the negative. Hook up the 20 gauge or the 32 gauge strand to that. Man, we could even do back EMF with this thing. Oh, that'd be fresh. Oh no, I said that. I said fresh. Yeah, I did. Oh yeah. So with these two coils, I know exactly how big they are. On the pulse motor down here, this pulse motor right here, we got 350 turns of 20 gauge, 24 gauge, and 32 gauge. And in Big Red, 666 turns of 20 gauge, 22 gauge, and 30 gauge. Big Red's the one that's running right now. The other one's not on. I love this kind of rotator though. It's one of my most successful builds. I built 4 of them, I think. I got one that's incomplete that I'd love to finish. So it's virtually a top that spins like so, and the rotor should spin the other way if everything's hooked up right. So it'll spin like so, and the rotor should spin the other way, and if it gets in sync, you should be able to let it go, and it should spin on its own like a top. But this one's gotta get a little bit more speed to it. Like, you got your it's got to get some speed so it'll start spinning, and then the imperfections will melt away, it'll disappear, and then eventually it should spin on its own. At least that's the theory. Very cool, I think. So the top, virtually it's just the top. You got your coils on the base of the top, then you put your rotor over the top, resting on this flange right here. It shouldn't touch anything. And then you got either your reed switches or your two N2222s. A transistor, small one. You might even be able to use a big one, I don't know. But this one's got 2 reed switches, one for each coil. Two 9-volt battery packs. Yeah, good to go. But those reed switches are in the wrong spot, or I'd be running this thing like crazy. Heck yeah, man, that's going to be awesome. Should make a rotor that kind of looks like the bottom with some copper infused. Now, I do think I have a problem with it being copper infused, and I bumped into this, like, it grips the magnets on the rotor, so it syncs up. It's not supposed to sync up. So I don't know if 9 volts is enough. Enough juice to overcome the grip that the copper has on the rotor. So if I can get that to be overcome, I won't have to make a new base. But I don't know, 9 volts is it's not enough, in my opinion. Because it syncs up. I mean, the copper just pulls it right along in the direction that it's spinning, and it's, you know, without that pull, it won't do that. Here, let me back it out. There we go. So we got an AC hookup currently. Now I have 63 volt capacitors with 4700 microfarad. I'm gonna hook this up as a BEMF collector. You know, I think I have one of these pre-built. I need to get new diodes though. Oh no, this will work. All right, so we got rectifier diode, making sure that the energy goes into the cap. Then we got the energy flowing out of the cap. Now, which way you hook this up determines whether you're getting regular or BEMF. And you got to hook up in parallel to get BEMF. So we're going to hook this end of the 24 gauge and the other end of the 22 gauge. And then we're going to move the multimeter over to the cap. So I believe we're going to read this the same way. Positive side of the cap goes to positive side. Negative goes to the negative side. We currently have 22 volts in the cap, so I'm lucky I didn't get zapped for not paying attention. Yeah, okay. Should have discharged that, but we're good. We're well below the threshold. Now, I'm not sure exactly what's going to happen right now. Looks like we're losing voltage, so it's well above its what it is going to give us in BEMF, so it must have been hooked up the other way, because it'll charge really fast the other way. See, that's what I was talking about. Sometimes it won't. The bench power supply won't kick in. We got a BEMF connection on the 2. And I think this is right. I don't think we're even making anywhere near that much voltage in BEMF with these 2 coils. No way. There's no way. It's because the inductance of these coils is very low. This is 666 turns. That's very low inductance. And this one's 350 turns, so that's even lower. So this is exactly what I expected to see. I didn't expect to see the 22 volts in there. I really didn't expect that. $3,000. See, so 22 volts above the line. That's awesome. Yeah, you can't see that very well. It's unfortunate. Maybe I can move it a little closer. There we go. A lot less glare over here. Or no, 3200. That's awesome. That is 12.5 volts in, 0.5 amps drawn, 3200 RPMs. We're generating less than 22 volts of BEMF, so that's going to continue to drop off. I'm going to flip it around though, just to make sure everything's working right. And people keep asking me, what's that sound? What's that rumbling? And it is the magnets themselves are, there's like less than a millimeter in there for them to move around. So I can take them out with ease. They sit all the way in there. So I'm not really worried about it too much. Sometimes I worry about it, like when I reach speeds that I haven't reached before, I'm a little nervous. But I think it's a pretty solid build compared to what I used to do. And that was, I would stick the magnets on the edge of the rotor, like have a little hole, and just glue them in. And that definitely didn't work. So if you're going to build a rotor, don't build it like that. So that jumped up. Bingo. that's EMF. That's the AC charge off of the strand hooked in series with the two strands. That's the reading you get. So cool. 3,000, 3,100. Nice. So now I think that cap will run. It's either going to run it or it's going to slow it down faster. I think it's going to work as a brake as it draws this capacitance out. It's going to slow it down faster. Oh yeah, 1,600. Sweet. So as soon as I get the information that I need, I'm going to move forward with my input-output swap relay. It should be pretty fun. I'm going to use one of these. Well, two of these, two 12-volt batteries, and the input and the output of the SSG. And that's pretty much all I'm going to use. And it should swap the batteries. Well, what it's going to do is it's going to swap the input and the output to each battery. So something that I am planning on doing is running a quad motor, basically. I'm going to use 3 coils wrapped as such, 777.7 turns of 24 and 2 strands of 32. I'm going to use 4 of these. And they're each going to have their own transistor and their own battery pack. 12-volt battery pack. So we're going to see how fast the 24 volts can get us going, considering I like how smooth the ride is. 24 is a smooth ride. Huh. I wonder if I replace this diode here with this setup instead. So we'll clip this to here. Save this. We'll unclip this one. So now we have a capacitor in there as well as the diode. We'll monitor that. Right. There's 1.3 in there, but I think that's going to change. That's the Trifiler strand. Awesome. This is virtually not now. I got the coil right up in the business here. That's a lot smoother, I think. So I don't really know what's going on right now. It looks like a leveling off, pretty much. The other side's going up slowly. What I mean by other side is we got a capacitor over here and one over here. This one over here is being monitored by this multimeter, and that one over there is being monitored by the other multimeter, which is now reading 28.8 volts. I think this is about 2600, 2596, 2600. So we got 30 in the other one, and this is still tapering down, so I don't know what's going on with that. It is now in a loop though. The capacitors and the diodes have created a loop. I don't know why it's not bogging down the motor more than it is. I mean, it's only taking away 400 RPMs. Still whipping at quite a pace. Now if I back this out, yeah, there it goes. That one continues to drop, and this one continues to gain. That's I guess that's balance in a nutshell, right? That's sweet. Now let's see how quickly it slows down. Because if it doesn't slow down fast with this, we're gonna flip them. We're gonna run it the same way, and we're gonna get that brake down. We're gonna get that down. Matter of fact, I'm pretty sure they go the other way to run as a brake. So that's what we're going to do. You know what? I'm going to disconnect these first. Sweet. All right, now let's hook this up the right way. don't know. No. But I'm going to hook it up anyway. I don't think this is going to work. Maybe the SSG light did not go on, so we're good there. Oh, yeah, we got to hook up this meter first. Let me turn that off real quick. Okay. Now I spun it clockwise that time. I don't think it really matters too much right now which way I spin it. Now we're going to get it up, speed it up, and then we're going to turn it off. We're going to see if we get a break effect from having it hooked up. Then again, these are not hooked up into each other. They are hooked up into each other. They're not hooked up into themselves, which may be an issue for this particular experiment. But we're going to find out real soon. And then I got one more way to hook this up, and that's right into themselves. And I think that's what we got to do. It does, however, sound like it's slowing down a lot faster, though. Let me get my readings here. Oh, that's still going 2,000. That I don't think is the what we're looking for. So. Okay, so this is the positive side. We're going to connect to the positive side. We're doing these in parallel. A BEMF collection plate, basically. Now let's hook up the other one. So, positive, negative. Now we don't have a clear reading. Oh, we do on this one. And this one looks like nothing. Yeah, 0. So I must have cleared that one out. Or what do you call it? Discharged it. Didn't seem like I discharged it. I must have discharged it into the wire. All right, now we have them each collecting on their own strands instead of having them connected. I think this will work out better. All right, it's taken from our output. What I mean is our output light is no longer running. So this connection, the SG does not like this. The SSG does not like this at all. It doesn't look like we're getting any action either. So maybe, see now watch this. Bingo. Something about that SG doesn't like. So I'm going to swap these. Still doesn't like it. Yeah, something's not right with that. Oh, that's what the freaking problem is. Yeah, no, that's why it's not working. It was running really good without the Trifiler connection. I don't know. I don't feel like it should be that much of a load, but it definitely works as a brake. Let's try hooking this up in series. So out will go here, and then yeah, this doesn't even look like it's gonna do anything. All right. Let's find a designated start, and then it'll make more sense. And it's going to start at a coil, not a power supply. Typically, it would start at a power supply. I think it's going to start right here. And then maybe we'll make another one if we need to. I think this would be a typical connection for drive coils. To smooth out your ride a little bit. No, this one isn't going to go here. This is going to connect to here. And this one is going to go over here. Need to get some clip. And there we go. I think this one's going to hook to the multimeter. If I've already got a clip, then we're going to hook this one to the multimeter. All right, let's see what we get. SSG likes it, so that's good. It's a monopole DC motor. And we're currently trying out different capacitor configurations with our Trifiler coils. Me personally, I'm not exactly sure what I'm watching with this multimeter though. I know it's hooked to that capacitor over there on the far end. But it looks like it's either hooked up backwards, which I know it's not. Oh, that's what it is. One end's hooked up here and the other end's hooked up to the other side of that cap. So it's the whole loop, including this cap, that is being read over here. Wow. Negative voltage. That's kind of cold, I think. Yeah, that's on the whole circuit. But here, let me just move it over to this cap. Should get a better reading then. Yeah. Alright, now I brought that other clip. I'm gonna turn this off to do this though. I'm gonna loop it up. Oh yeah, that sounds like it's slowing down rather quickly now. There, now the caps are all looped up. So, I think I can run those two caps over to the power over here, and it should drain those caps and run this motor. At least for a second. I mean, that's what it should do. Alright, let's slow this down. Turn it on. Alright, yeah, that's already plugged in. That's cool. Alright, I think I'm definitely going to need an outlet for these caps now. $2,800. Sure thing, man. All the way. Sure sounds like it, I think. I mean, I don't know what to respond to that, but... I remember the old dial-up modems, man. They were loud. Alright, I'm going to cut the power. Yeah, I'm not complaining. I'm gonna try a different rotor real quick. This is an awesome rotor though. I mean, it is very smooth. It's a little loud though. All right, but this one, it's got iron infused PLA on the bottom, so it sucks the magnets in place. You won't get that buzzsaw sound with this rotor. But it doesn't go as fast, and it's a little off center in the middle, like a micro whatever off center in the middle. So it shakes the table a little bit. Isn't that nicer? Isn't that nice and quiet, kinda? I mean, all you hear is the motor, right? Yeah, Doohickey Corporation. Oh man, if I was that greedy. I mean, if you see something that you like, go ahead and take it. It's all free. Now this one doesn't move as fast, but it's nicer, I think. It's got a fan effect to it. Like 2,000 RPMs, but it's got a lot of drag. I can feel a strong breeze coming off of this thing. It's being sucked in through the middle and being pushed out through the sides. I think if it keeps it around 2,000 RPMs, that's a good feature. 19.5, so I think it's a good rotor. I guess with that wind, with that fan effect, you gotta kind of move it in close. Yeah. Because it's got a nice load on the rotor right now as it is. The way I built it. So it's got 4 spokes in the middle, sucks the air through the middle, down through the middle. I'm gonna get something smoky so you can see it work. Only problem is I don't have anything smoky at the moment. Unfortunately, there are no diodes on fire, there's nothing burning, so I don't know. I got some sage, I'll be right back. See that? Awesome, man. That is freaking cool. So kind of how I described it, right? It's actually like a vortex. A tornado of smoke. So cool. And then of course it pushes it out the bottom. And then really neat. I think it's cool. So that was a cool little display of what this rotor is actually doing. So neat, man. It is really neat. Chief engineer, man, I am blown away. I'm definitely not an engineer. I'm more of an artist, not self-proclaimed artist. I don't think I'm that good at art either, but yeah, these two have now equaled out at 49.5 volts of DC electricity. That's awesome. I'm more of a DIY kind of guy. And you know, usually when you're getting an education, there's like one thing that you get taught that like sends you on your way. Just one thing. Yeah, you got all the other stuff too, but it's that one thing that you're like, oh yeah, Eureka. I don't know, man. I had to come up with that on my own. I mean, my question was, can I make the rotor spin? Can I make the rotor spin without me spinning it? And that led me here. Okay? I'm not I'm not that guy who like has it all figured out before he starts. I am not that guy, man. I jump right in. A lot of people don't appreciate that. I mean, I could, if I was playing with anything higher voltage, I could get seriously hurt doing that. But you know, I do think I've been shocked severely by this stuff before, and I mean, it sucks to get shocked. But in the instances where I've been shocked, it wasn't enough to change my heartbeat or anything like that. It was just, it sucked. That's it. Yeah, so whatever. And this doohickey right here spins both ways at the same time. Let's just give it a second to get started. And if I'm not mistaken, I'm going to refrain from using that language because I think it's copyright. Just saying. LMR trains, models, and more, I think that's copyrighted. You know what I'm talking about. I think Disney's got a lockdown on that. I mean, I don't know for sure, but I mean, I know where that comes from. So, and I'm honored, really honored, man. I'm glad you put me up there with the doohickey and dingle hopper. That's awesome. Really, really cool here. Got 3 neodymium magnets on the rotor. And then we got 2 batteries in play. We got a third one to balance the weight, so it doesn't shake as much as it used to. Let me put it that way. We got 3 wedge-shaped coils that are 20 and 32 gauge. They're wrapped by hand. And then there's a couple other reasons why I think we only get 1,000 RPMs out of it. Like placement of the trigger coil, it works where it's at, but it can be tweaked and refined, and maybe a different shape trigger coil might work better. And this, of course, is just chilling here on a pole. The pole isn't even fixed to the table. It's just, uh-oh. Yep, I just pushed it. I pushed it down. That little flange, the nut, is the loose nut. Now I think I'm a little too high, but we'll see. I think we might be able to lower it a little bit, but I think this works. Great. It's the simplest of simple connections. I need to add a light to the connection. I think we'll get a lot more out of it if I add a light. When I say a light, I mean just this, like this light bulb right here. It's a 120 watt halogen light bulb. Or 120 volt, my fault. I said watt. It's definitely not a watt bulb. So I actually want to get a reading on that. Where did I put my... Oh well. I think it's actually moving faster being farther away. Yeah, that sounds a lot faster. And that's good because the rotor still moves, or I mean the stator, or the second rotor, still moves pretty good. Here it is, hiding behind the apparatus itself. We'll give it a little boost this time. Almost to 1,000. Anyway, it's a little like fun thing that I can do, and virtually anybody can do this. Make the counter rotators. Because what I've noticed is that all motors, if you untether the stator, they want to move the opposite direction the rotor's moving. That's awesome. I love this thing. It's completely untethered, man. There's no commutator or anything on it. Not that I have anything against commutators. I'm going to build a commutator for it just so I can get multimeter readings off of it. I'm going to use the commutator plate to hook up a multimeter to it. I think that's a good idea. It's going to be fun. Oh, I didn't even turn on this one. That's all right. Heck yeah, man. I think that's a graduation. Definitely, I graduated to the next level, man. We are now doohickeys. Dingle hoppers. And if I'm not mistaken, you get to eat with those and comb your hair and stuff. That's awesome. So I've got this core. Let's see what we can do with that. If this fits, I'll leave it in there. Yeah. Not quite. Yep, not quite. Need a little bit more tape on this, and then it'll fit. Mm. All right, I think we got it now. Now I don't know how this is going to change it very much. It's going to increase both. That's a nice core for that. Wow. Fits right in there. It's kind of neat. Now I do have, it's only iron infused PLA, but I think it'll fit in this hole. Our caps are getting pretty high. 63 volts. 61 over there. Whoo! Alright, it looks like we're capping out though. So I don't think they're gonna bust on this one. But I am wearing my protective eyewear just in case. All right, so we are definitely capped out. And that happened pretty fast with the cores in there. Now, I'm telling you, man, iron infused PLA will work for magnetic flux. It's just not going to work as good as iron. But it's 45% iron, done at 100% on the printer. So I can feel the magnetic, like, pull just from it being in there. I think it works okay. Not as good as like iron or chrome. Like I have this, and you can see that it's very magnetic. It's more of a steel, it's more of an alloy though than it is iron. It has a lot of iron in it, but it's more of a steel than anything else. So cool, man, so cool. So the caps are maxed. Wonder what I'm gonna do with all that energy. I'm gonna shut these off for now. Yeah, I'm not ashamed to have seen The Little Mermaid. Not ashamed. It was a really good movie when I was growing up, and I think I watched it like 4 times. It was a good movie. And I keep bringing it up because it's the only comment there. It's still chilling there. If anybody wants to help me get rid of that, that would be awesome. Whatever you want, man. Whatever you want. I'd hate to have to delete that because that's awesome. Nah, there's no way. There's no way I'm going to do that. All right, so I'm gonna wrap it up really soon here. So on the docket for what I'm gonna do with this motor right here, is I'm gonna hook it up in a double relay to swap the input and the output with batteries A and B. Okay, a lot of ways that I've seen it done is swapping batteries A and B with the output and the input. I'm just simply swapping that. If you get what I'm saying. I don't know if that'll work. I'm figuring that if the switch happens at exactly the same time on both relays, that it'll work. But I don't know, man. I mean, so I'm gonna keep a lid on it. I need to get in with computers and use the software to make my diagrams. It's just I don't know any good software to do it with. So I'm hoping that Mike will be able to hook me up with some software. I think he gave me the name of it. Yeah, I don't know. I don't know, man. I honestly, I really don't like doing this stuff by myself. And it's like this stuff got dumped on my doorstep. And then the people that dumped it there are gone. And I don't know what to do with most of it, so I don't appreciate that. Fair enough, right? Fair enough. Hey Scott, what's up? I just, if you're going to drop something on the doorstep, at least stick around long enough to tell me how it works. And then I got tons of my ideas that I want to break down with other people. And I don't know, man, just everybody's gone. Everybody's doing their own thing. Well, it's cool, man. I dig that. I do that a lot, but I really can't get any farther until I get to this brainstorm. And that's kind of where I'm at, man. Nobody wants to talk shop. I've thrown out some lures. They're out doing their own thing, and that's cool. But I don't know. Right now, I'm just kind of waiting around. And like I said, Mike, he gave me some software that I could use to boom, boom, make a good schematic. That's one thing I'm lacking is schematic skills. I don't know how to draw a schematic. It doesn't make sense to me how there's obviously like a rubric on how to make a good schematic, because I tend to have a tendency to see all the components kind of be in the same areas all the time. When I'm like, coils will be kind of to the outside. The inside is usually kind of open. Everything kind of goes around the outside. And then I don't know, there's definitely a rhyme to that reason. and I just can't grasp it. I want to learn how to write and read schematic. I can't do either right now. No, I think schematics suck. I mean, everything on my table is round, and you want me to draw it in squares? That sucks. But, you know, I'll be able to wrap my mind around that eventually, and hopefully I'll be pretty good at it. I got a lot of good ideas. There, one of my paintings from about 4 years ago. It's pretty neat. It's just a road going into the background. Just chilling there. And while we're wrapping up here, I want to show you something. Thanks for sticking around. If you want to see this, this is pretty cool. So I call this guy, this little guy here, he's called the green one. And you can, it's done with black and white paint, or black ink, black light paint, my bad. And he's a little Gumby character. Put that right there. More black light paint. Got my infinity related symbol. It's basically an infinity and family symbol intertwined. So I call it infinity related. That's mine. And then this one is not black light lit, and that's okay. But it's a nice little like lotus puffer plant like thing. It's pretty cool. And if you can't, if you didn't guess by now, those are my initials. Okay, so M.P.H.Jr. is me. That's who I am. Papa Bale is my alter ego. See? These were done years ago. See, and I'm all about bridging gaps, man. There's not like this is all awesome art. You know what I'm saying? You put it in a black light, you can see it 10 times better. But that's my little Gumby character. You can kind of see him like that. My infinity related symbol. So you got the family, the familia symbol, and the infinity symbol intertwined. Got a lot of paintings like that. And then of course my, I want to call it a pom-pom flower. Kind of like a lotus, a puffy lotus. Anyway, man, that's where I come from. I love art. I love doing things that people hate and making them beautiful, because you're wrong. If you're going to judge somebody's art and say that it's not good, you are wrong right off the bat. I'll say it straight up. I'll be that guy that says, you have no idea what you're talking about. And it's like, because everybody's not a Rembrandt, that means they shouldn't be an artist. I don't know, man. Don't know about that. I think if anybody should be punished, it's the judge. So cool, man. All this is great. I love making rotors that are, they're artistic. This rotor actually, sucks the air in the middle and spits it out the sides. It's very awesome. And that produces a fan-like load on this rotor, so it only spins 2,000 RPMs. It's 5.5 inches on a toroid with 4 magnets. And yeah, it sucks the air right down the center, man. That's basically what I need for my turbine thing that I'm working on. Anyway, thank you all for hanging out. I really appreciate it. We're going to cut it a few minutes early today. Thank you very much. Peace out. Have a great day. Please subscribe. Bye now.